Hello everyone. You are on the Another Space channel. Venus's closest neighbor may have once had rivers and oceans that supported life, similar to those on early Earth. Its burned-out surface today is a global remnant of volcanic destruction. Under a dense, toxic atmosphere, scientists have developed new, daring strategies to explore the planet's tortured landscape and search for clues of a time when it was alive. How did Venus fall into this hellish state? How did Earth survive? The air at the surface is composed of 95% carbon dioxide. It's so dense that it looks more like an ocean. It's hot enough for lead to melt. Thick clouds of sulfuric acid are visible in the sky. A spacecraft that stayed on Venus for more than 2 hours holds the record for the longest duration to date. We have only seen a few close-up images sent by the Soviet Venera landers back in the 70s. The radar images from the Magellan mission in the 1990s have stoked the desire for more. We imagine it to be a forbidding place with eroded rock and a crushing atmosphere, based on the few Russian lander images. When you look at Magellan's images and see the bewildering array of volcanic flows, canyons, valleys, and channels that were carved out by liquid lava or volcanoes in different shapes and sizes, I think Venus's surface is beautiful. In ancient Asia, skywatchers observed Venus as two distinct stars, the brightest morning star. The exalted western one would be the evening's entertainment. It always flirts with the edge of the night. Venus will never be visible at midnight in the sky. There's never much time between dawn and dusk. Sumerian priests regarded it as Inanna, the goddess of sex, fertility, beauty, and attraction. For the Greeks, Inanna was Aphrodite, the Hellenic goddess of love, born from the foamy sea and protector of sailors, beckoned us to explore the unknown. The Romans dedicated the month of April to Venus throughout their empire. The Romans celebrated Veneralia to honor purity, piety, and matters of the heart. Across the Atlantic, Venus was viewed as the younger sibling of the Sun. The Mesoamericans were among the best observers of Venus, along with the Aztecs and Maya. In those cultures, Venus was a male warrior wielding a spear who went down to the underworld to fight the enemies of mankind. Venus is a feminine figure that we associate with Botticelli. Around the globe, Venus has taken on many different forms. The mythical Venus gave way over time to scientific scrutiny. Galileo Galilei noticed that Venus's crescent changed phases just like the moon in 1610. Another clue that planets orbit around the Sun. Galileo was unable to discern the features of this planet even with his telescope. In May 1761, the Russian astronomer Mikhail Lomonosov was able to discern its unique character thanks to a rare alignment. Venus passes between the Sun and Earth about once every 100 years. You can see the little dot of Venus as it moves across the face of the Sun. In the very first and very last moments when the dot moves away from the Sun's disk, something strange happens. The black drop is a distortion. The Sun's edge almost looks like it leaps towards the Sun, then becomes distorted inwards. Lomonosov realized that this would be logical if Venus had an atmosphere. You can then calculate the diameter of Venus. They said, "Oh wow, it's about the same size as Earth. It's bigger than Mars and yet so bright. Why is it so bright?" "Oh, it must be covered with clouds." They were also right. At that time it was assumed, and this was reasonable, that clouds were made of water. The idea that Venus is similar to Earth inspired fantasy and science fiction writers. When I was a child, I read a book that claimed that Venus could have dinosaurs and prehistoric jungles. I thought it would be exciting, but it was nothing like that. Mariner 2 was the first mission to reach another planet at the dawn of the space age. Mariner 2 was the first spacecraft ever to fly by Venus in 1962. It was a groundbreaking discovery to find out that the surface of Venus is very hot. This was bad news for Venus exploration because the old ideas that Venus could be habitable and have people living there were debunked. Stranger yet, NASA's Mariner 2 discovered that Venus rotates backward and very slowly compared to Earth. Americans celebrated their achievement. The Soviet Union, not to be outdone by the United States, attempted at least 16 missions to Venus from 1961 to 1984. Venera 7 successfully landed on its surface in December 1970. It was the first time data had been transmitted from the surface. Venera 9 and Venera 10, which were launched in 1975, captured the first images of Venus's tortured landscape. The American Pioneer Venus orbiter started a 13-year mission of radar mapping in December 1978. Then, a Pioneer multiprobe was deployed in the atmosphere. Atlantis Houston. Sunnyvale has a successful direct check, and their command is now complete. NASA's flagship Magellan was launched from the space shuttle a decade later on a 15-month journey to Venus. The Magellan imaging radar, which looped pole to pole over 4,000 times, mapped 97% of Venus's landforms. Magellan discovered that the surface of Venus is covered by a thick volcanic crust. Evolution of Venus. Venus looked remarkably similar to Earth about 3 billion years ago. Both nurtured the promise of life. They are the same size. They formed roughly in the same location. Circumstantial evidence suggests that Venus's environment was more Earth-like when it first formed. They may both have had warm oceans, and all other conditions needed for the origin of life when Earth had its origin. We have very little information about Venus. Its ancient past is fascinating. A planet's surface and atmosphere are similar to a crime scene. Venus is the most horrific crime scene ever imagined because it has been almost completely altered over time. The big question is, when did Venus's evolution diverge from Earth's? Venus and Earth are twin planets. The only planet likely to still be geologically active besides Earth is Venus. Venus is a great laboratory to understand Earth because it has many similarities and some differences. Venus is the evil twin sister of Earth. This shows that two planets with similar sizes, densities, and distances from the Sun can have very different evolution paths. Early on, Venus followed a similar path to that of its sister planet Earth. Radar data can reveal clues about a past filled with water, such as vast plateaus of granite rock that formed on the bottom of an ancient ocean. Some areas of Venus look like continents. They're high-standing. They are a bit wrinkled. Venus's history is also reflected in the rocks, which are among the oldest on Venus, where much of the surface area is new. These rocks represent the first 80% of the history of Venus. This is where we are going. These areas are known as tessera terrane due to their tile-like appearance. In my mind, I can't understand why the origin of life couldn't have occurred there. We're searching for this record in the rocks of Tessera. Is there evidence of ancient environments that would have supported life? Venus is close to Earth in size, mass, and rocky composition, but that's where the similarities end. Now, one thing we've learned in general about the formation of the planets is that the final stages of planetary formation were characterized by a small number of really enormous collisions. Those last few violent collisions happened on Earth in just such a way as to leave it with a moon, and on Venus, through a different combination of impact size and impact angles, it may have been left with no moon, but with its very slow rotation. Compared to our 24-hour day, it takes more than 243 Earth days for Venus to rotate just once, the longest day in the solar system. And it rotates in the opposite direction, so that if you were on the surface of Venus and could see the Sun, it would rise in the west and set in the east. On Earth, The sun moves along in the sunrise at hundreds of miles per hour, so you have to be up in a jet airplane if you wanted the sunset to last forever. On Venus, though, it's 4 or 5 miles per hour, so you could kind of walk along at a good clip and keep the sunset going or the sunrise going as long as you wanted. The pace of the planetary rotation is a human walking pace. Even that slow pace may be winding down. The very thick atmosphere of Venus is actually being pushed and pushing back from the topography and changing its rotation rate very slowly and very slightly over the decades. And that has been measured by ground-based units and by Magellan, and even by Venus Express, the most recent European mission. Though the surface creeps along without hurry, the clouds move quickly and their speeds change. The Japanese Akatsuki probe, also known as the Venus Climate Orbiter, recently found that the atmosphere spins much faster than the planet itself, a phenomenon called superrotation. This movement is driven by heat rising continually from the surface. Mysteriously, the planet lacks a key feature that protects Earth and its atmosphere, a strong magnetic field. Without this protective shield, intense ultraviolet rays from the sun split water molecules apart in the high atmosphere. Then the sun's intense stream of charged particles, the solar wind, carries much of the hydrogen away into space. The sun wasn't as bright in the early solar system. Venus was more habitable. Just a tiny bit more solar brightness would be enough. The oceans began to evaporate, causing a greenhouse effect that was uncontrollable. Water vapor in the atmosphere increased the greenhouse effect, and the planet became the hot, dry planet it is today. We are certain that Venus used to have much more surface water than it does now. It could have been an ocean of water. We have no idea when the water was lost. This water could have lasted for billions, if not for trillions of years. On Earth, life developed incredibly fast, especially when you consider the meteorites that hit the Earth. Why not Venus then? If the answer is, it did not happen on Venus, then that also tells us something. Carbon dioxide is a primary cause of the loss of water on Venus. Venus, however, lost the ability to capture that carbon and became trapped in an unimaginable loop. The oceans eventually boiled away, partly due to the greenhouse effect that water vapor has. This led to a positive feedback loop whereby the more water evaporates, the hotter the planet gets because of this greenhouse effect. The carbon cycle is destroyed when the oceans of Venus are lost. You still have CO2 coming from the volcanoes, but you can't remove it. When the water vanished, the sink vanished, and the thermostat shifted to the red zone. This is because the CO2 in the atmosphere continues to increase due to volcanoes. It can't lose the CO2 without water mediating it, so it ends up with a runaway greenhouse. Why did volcanic CO2 run away on Venus while Earth kept it at trace levels? The geology of both planets is fundamentally different. Earth, just like Venus, has a core made of molten metal. The radioactive decay of uranium and potassium over time generates heat. Earth's thinnest crust, the oceans, is where hot liquid rock is pushed through. The seafloor is flooded with lava. Plate tectonics is a method of creating plates by growing mountains under the sea. They can also dive under them when they collide with continental crusts that are thicker. The friction from the rocks causes them to melt. Oceanic water speeds up this process. Pressure increases until a volcanic eruption occurs. Up to 80 eruptions per year are caused by plate tectonics. This process can sometimes release large amounts of energy. It changes the course of Earth's history. Yellowstone National Park, located in North America, is a living laboratory for Earth's geology. It is possible that the rich mixture of organic chemicals and geothermal energy in these places may have led to the emergence of living organisms millions of years ago. A dome of magma is responsible for the hot springs and other geysers that we visit to see. There is a lot of construction going on underground. This dome is pushed up by the Earth at intervals of approximately 600,000 years to form a wide plateau. Hot gas and lava will inevitably explode through cracks in the ground. The plateau collapses violently, causing eruptions that are so massive they would cover the continent in ash. Plate tectonics really is what makes Earth tick. Plate tectonics, in a way, is what organizes Earth's behavior. The carbon cycle, the climate cycle, and even continental drift are all part of plate tectonics. Plate tectonics is responsible for all the other features of Earth, such as the way that things move between the interior of the Earth and its surface. Venus does not have plate tectonics. By examining the crusts of these sister worlds, you can understand why. Earth's crust is only 8 kilometers thick under the oceans and 30 kilometers thick under the continents. The crust of Venus, however, is twice as thick and acts as a rigid lid that holds the surface in place. If Earth had not experienced volatile cycling for most of its history and instead we were in a plate mode like that on Venus, all the nitrogen and carbon dioxide we see on Venus would also be present in our atmosphere. It is possible that the dense crust of Venus never separated into continental plates. But the heat still has to find a way out. Venus is an extremely volcanic planet. The majority of Venus's surface is actually covered with volcanic ash. Volcanoes are a diverse group of volcanic formations. From the smallest feature that we can measure with the radar data, about 100 meters for each pixel, to massive lava flows stretching thousands of kilometers. The Magellan mission recorded a variety of different types of volcanoes. Venus is home to some shield volcanoes. Shield volcanoes are low-sloped and look like warrior shields on the ground. The name comes from this: it's not just shield volcanoes. Venus has several different types of volcanic features. We don't find these anywhere else in the solar system. One of the most unusual types is a dome we call a pancake dome because it really looks like a pancake. They are flat at the top. They have steep sides. These domes are also called ticks because they resemble squashed bugs. Arachnoids are so named because their fracture pattern is similar to that of a spider web. There are some concentric and radial fractures. After all, the enormous volcanic features known as coronae may indicate that Venus is subducting rock back into its interior. Corona on Venus has a similar pattern to a caldera on Earth. There is a collapse or a series of collapses. Like in Hawaii, a plume of hot material rises, pushes the surface up, breaks the surface, and forms a bunch of volcanic activity at the surface. The two volcanoes which form the Big Island span a combined 150 kilometers. Some of the coronae have gotten much bigger on Venus. Two very large features stand out. One of them is 2,600 kilometers across. Volcanoes on Venus are the main way we think Venus has or is losing heat. Volcanism is the record of how Venus tries to cool down and how it loses heat from its interior. About 500 million to a billion or more years ago, something catastrophic happened. You can see the surface of Venus from satellites. If you count all the craters on Venus's surface, you will find that it is geologically young. Venus's entire Earth-sized area was covered in volcanoes 500 million years ago. We're still trying to figure out what happened and why. Lacking a magnetic field and with its rapidly declining water stores, Venus's surface is doomed to climate death because it has no plate tectonics that would have dragged carbon into its crust. Instead, hordes of volcanoes are releasing CO2 into the atmosphere. The planet has been turned on its side. Earth, Earth's sister planet, has managed to thrive and develop a complex biosphere. One of the most important quests of science today is to understand how Earth and Venus differ. searching for solar systems or life-bearing planets in the galaxy. This search is being conducted by an increasing number of observatories on the ground and in space. The search has so far revealed over 4,000 planets, with thousands of others detected but not confirmed. Exoplanets have been growing in size and are becoming more similar to Earth and Venus. Statistical studies suggest that there may be billions of exoplanets in our galaxy. They orbit within the habitable zone of their solar system, where water is present in 3 different states: liquid, ice, and steam. Is intelligent life a product of nature's laws? Is it just a fluke or a coincidence? All that can go wrong in planetary evolution is a major factor in reducing its chances. Venus hasn't answered all of our questions yet. After we started to understand Venus better, scientists and space enthusiasts have been saying for years that Venus was the only place they didn't want to visit because the surface is so hot. It's hot enough that it could melt the land. It turns out, just like on Earth, that the temperature drops as you go higher up in the atmosphere. There's one region on Venus that is very similar to the sea level conditions here on Earth. The presence of hospitable environments in Venus's upper atmosphere led to the development of one of the most inventive mission ideas ever. Imagine a vehicle that could penetrate the outermost layers of Venus's upper atmosphere. It deploys an inflatable envelope instead of continuing onto the surface. Airships are up to 130 meters long. This platform is called the High-Altitude Venus Operational Concept. Would host a number of sensors and experiments. It's also very wide-ranging. It is the beginning of a permanent outpost for humans. The Science City of Venus is a built-in cloud. The concept makes use of the unique profile of Venus's atmosphere. The pressure at ground level is equivalent to being 900 meters below the surface of Earth's oceans. It is hotter than any other place in the solar system except for the Sun. The pressure is the same as the sea level at 50 kilometers above the Earth's surface. There's nothing warmer than a June day in Europe or America. This is where habitats born from balloons could float forever. Imagine a team of scientist astronauts on an airship. On their way back from a survey, the ship's solar-powered electric motors are navigating through the clouds of sulfuric acid. The inside pressure of the balloons would be about the same as the outside pressure if the balloons are very, very big. In a catastrophic failure, it wouldn't explode like a balloon. These sequences depict a highly developed version of a Venusian cloud city. Construction of such large and complex stations depends on the ability to extract materials like carbon fiber directly from the atmosphere. Its primary mission is to act as a base for the deployment of research probes all over the world, including in hostile terrain. These experimenters will use their floating platforms to investigate the deep history and connections between the land and atmosphere of Venus. The scientists would look for signs of active volcanoes, as well as the interaction between the physical, chemical, and biological components of the atmosphere. All this in an attempt to find out what went wrong on Venus. First demonstration of balloon science by Soviet researchers, the 1985 Vega 2 probe navigating turbulent thermal currents at 240 kilometers per hour. The 3.5-meter balloon of Vega 2 reached a stable height of 54 kilometers. It traveled 7,400 kilometers around the day side of Venus in the most active cloud layer of the planet. Vega 2 descendants can be deployed from airships in order to sample altitudes. They could triangulate their positions to form a global network of sensors that would detect signs of seismic activity. Our balloon can detect earthquakes while it is floating around Venus. This takes advantage of the thick atmosphere on Venus, which allows sound waves to propagate through the atmosphere. These can then be measured by a balloon or even from orbit. It's astounding. Venus's atmospheric features are complex, even though it appears as a flat cloud bank covering the entire planet. The molecular fossils left behind in Venus's atmosphere are one of the most important things we can learn about. Noble gases such as argon, neon, xenon, and krypton are those that do not react with other gases. Since Venus formed, they've been present in the atmosphere. If we can measure them, they give us fossil evidence. This is what the original atmosphere of Venus looked like. The profile of Venus's early atmosphere will tell us if it once had lakes and rivers. It's possible that if humans visit the acidic clouds of Venus someday, they will find out, in a strict sense, that they are not alone. Astronomers have been observing mysterious dark patches on Earth for more than a century. These appear only at UV wavelengths. What my Venus atmosphere friends are talking about is the fact that the atmosphere has a signature that they cannot explain. They don't even know what the cloud is that absorbs UV radiation. This signature could be caused by absorption by biota. Cloud creatures. There is nutrition, there's liquid. Many of the things we consider essential to life are not. We may think that the acidic clouds are the only thing stopping life, but in recent years we have learned about all the extremophile organisms living on Earth. These include organisms we call acidophilic, or organisms who love to live in strong acids. Thiobacillus ferrooxidans is one of the bacteria that exist on Earth. The absorption spectrum of Venus is similar. Could life have evolved and migrated up as the surface became lethal? Microbes can be found in the Earth's upper atmosphere at an altitude of up to 40 kilometers. Earth has had 4 billion years to fill all ecological niches. We find life in every corner of the world. We find life in the deepest wells. In the clouds, we find life. If we had the chance to go to Venus and float in the Venus clouds today, we would at least consider if there are any conditions in the Venus clouds that could be suitable for life.
The hot surface of the Earth is merciless, even though the tops of the clouds may be mild. Venus engineers have to take a mechanical route because even the toughest electronics designed for the military will stop working after 125 degrees Celsius. I'll show you. This is a stainless steel clock. The clock has been operated in an oven at 460 degrees Celsius. Our goal was to begin to understand what challenges you face when building mechanisms that operate under Venus conditions.
The spring material is very important. Inconel is used to build both the clock spring and the balance spring. The entire assembly will expand and contract as one, even at extreme temperatures like Venus, 462 degrees Celsius. We were able to demonstrate this by using the clock. Like Mars, the surface of Venus requires mobility. Venus is a different planet. Strategies that work on other planets do not work here, not even solar energy. Venus has some solar power at its surface. The thick clouds, the red shifting of the light, and the fact that solar panels are less efficient make it possible to only have a fraction of the energy available on Earth. Venus's long night of about 60 days is another big problem with solar power. The wind is one source of energy that we are looking at. You can use low-speed and high-density winds to power your vehicle. A wind turbine will collect the wind, which is then transferred to the wheels for low-speed but high-torque driving. You can use the wind power to drive mechanically on Venus's surface. We have sensors on the surface. We have the radio at the surface. Most of the computer processing power and other things needed to run the mission will be located high above. We could put them in an aircraft flying 50 kilometers above the Earth, or perhaps in a satellite. The winds on Venus are quite fierce. The wind speed of Venus is 100 meters per second. We could fly and follow the wind, but we'd have to be able to fly faster than the wind in order to stay in the sunlight. Venus's extreme heat on its surface creates a toxic atmosphere. The planet is located within the habitable zone, as astronomers define it. Venus is an interesting case because it makes us think about where the outer edge of the habitable zones is. It's probably somewhere between Earth and Venus in our solar system. There was probably an ocean on Venus at a time when Venus was in the habitable zone of our solar system. Mars used to be warmer and wetter and had more atmosphere, as we believe it did at one time. Venus had a much lower atmosphere and more water in the past than it does today. It is very dry today. It's possible that when Venus had less atmosphere and more water, it could have been habitable. We are certain that the planet has changed. Astronomers have been studying the Milky Way galaxy to gain a better understanding of planet formation and conditions that can support a world like Earth. The other exoplanets are too far for us to learn much about them. Venus gives scientists the chance to better understand our neighboring alien planet. There are millions, if not billions, of planets like Earth and Venus. We'd also like to know what caused the desert to become so hot. Earth, on the other side, becomes a planet that is habitable and has liquid water. Venus has evolved in different ways, and this would make it habitable. This tells exoplanet scientists that they shouldn't just dismiss these worlds as inhospitable and hot, but that they should take a closer look. This would bring the habitable zone closer to the star. When we gaze out at the galaxy and see so many planets that look like Earth, aren't we looking for another Earth? We are looking for a place similar to ours. The closest Earth-sized world is the one that's closest to Earth. It's Venus. It's there. It tells us how Earth-sized worlds are formed and whether they're habitable. Two planets of nearly equal size and mass were born together, made of the same material. Each of them began their lives with oceans and air laden with water vapor. As time passes, we become more and more engulfed in the greens, blues, and life itself. The other was engulfed in a toxic fog. The surface of the crater was covered with volcanic ash. What types of worlds are most common in the universe? We have a great deal of knowledge about Mars. We have sent 12 probes to Mars. We have sent rovers to explore the surface. We know very little about Venus. So we must learn how to get there. Learn about the weather, climate, and the movement of Venus. Venus must not be forgotten in the solar system. Understanding Venus teaches us about Earth. When we see the world in the correct way with the right drones, spacecraft, or humans in protective suits, we will be amazed. This place is huge and beautiful. There is much more land on Venus than on Earth, since Earth is 2/3 water. It will be a fascinating place to explore when we have the chance.